So, for example, this is all these are part of the example 1 in the book. And the way that they're doing it, I mean, to me, when I see 125 to the 1/3, I think, oh, that's the third root of 125, that's 5. I don't need to translate it. It's like speaking a foreign language. I don't need to go back through my language to understand it. But what they're doing in the problem, that is what they're doing. They're saying, oh, this means the third root of 125. And then maybe you see it clearer at that point. So, oh, yeah, I know what that is. That's 5. You may see it when you see 125 to the 1/3, because it is just another way of saying the same thing. You know, this 5 to the 1/2 times 5 to the 1/2, if you wrote it as radicals, that would be the square root of 5 times the square root of 5, right? We've already dealt with that a lot, right? What is the square root of 5 times the square root of 5? It's 5, right? Now, personally, I would have looked at that and said, oh, 5 to the 1/2 times 5 to the 1/2, that's 5 to the 1/2 plus 1/2, properties of exponents, which is 5 to the 1, which is 5, right? 5 to the 1/2 plus 1/2, which is 5 to the 1, which is 5. I mean, that's why it's equivalent to take the square root of something, is to raise it to the 1/2 power. Because again, if you times it times itself, you should get 5. If you add the exponents, you get 1. All means the same thing. You know, this one here, but you can do this different ways. I mean, personally, I think of this more like a property of exponents. You know how we have the one property of exponents that says, if I have an exponent outside parentheses, I can always distribute it to everything that's inside. Well, in this case, I've got 10 to the 1/3, 100 to the 1/3. How about if I bring that 1/3 then outside parentheses? It's kind of like factoring, right? Now, 10 times 100 is 1,000. So this is 1,000 to the 1/3, also known as the third root of 1,000, which is 10. Right? I mean, you could have turned these into radicals right away if you wanted to. Then it would have been a proper product property to put the radicals together. 16 to the 1/4, we just did that one on the first slide, right? That was 2. This 2 to the 1/2 times 2 to the 1/2 is going to work just like 5 to the 1/2 times 5 to the 1/2. It is 2. And this 2 to the 1/2 times 8 to the 1/2 will work just like this one did, right? That would be 2 times 8 to the 1/2, which is 16 to the 1/2, which is the square root of 16, which is 4. Right? So we're just seeing at this point that we could represent taking nth roots of things by raising them to that fraction as a, yeah.
When there's two different numbers, will they ever be raised to different powers?
Could it be like 2 to the 1/2 and 8 to the 1/3? It could, but it's not always simplifiable like that. You might have to like turn them into decimals.